Okay, so here we are on video number 3 for lesson 4.2. So again, same skill. We're solving algebraic equations that have variables on both sides. I'm still on page 204. But now, as I pointed out, the third video is going to be about fractions. Okay, so we have 3/4 x minus 1/2 equals 3/8 x plus 4. So let me make sure I wrote that all correctly. 3/4 x, again, I'm on page 204 if you're following along. All right, so we've got x terms. We haven't introduced any other variables yet into this concept. So again, I talk about moving the coefficient that has the smaller value. And fractions, you're like, oh, it's so much harder to tell if it has a smaller value or not. But in the example that we have here, 3/4 or 3/8. Now, I looked at 3/4. You're all pretty familiar with what that is in terms of size or value. But 3/8, I think of those benchmark fractions. So I'm like, well, 8's, what's half of an eighth? 4/8. All right, well, this is smaller than 4/8. So this is smaller than a half. So I know I'm going to move this one because this is 3/4. This is 0.75. That's bigger than a half. So this is clearly smaller because it's less than 4/8. It's less than a half. So I'm going to move this one. So it's a positive 3/8 x. So I have to do subtraction, right? I'm undoing this one. I'm trying to get it to 0. So I'm trying to undo 3/8 x. The only way to undo the positive 3/8 x is to subtract 3/8 x. I'm going to do that on this side. I need to do it on this side. And again, this is where I tell you need to be doing your work out. So negative 3/4, and I'm sorry, does it negative? 3/4 x minus 3/8 x. So to do subtraction with fractions, they have to have like denominators, right? And this is already 8, so we're going to just convert this one into 8s. So we need to double the fourth to be an eighth, right? So 3/4 is the same as 6/8. And if you didn't understand what I did there, pause the video and try it yourself. To convert 3/4 into 8s, you have to double fourth into 8. So I have to double 3 into 6. So I'm just trying to move this along and keep it pretty straightforward. 6/8 x minus 3/8 x means that I am going to have 6 minus 3 is 3/8 x, right? And this is they're both positive. So I'm taking 3/8 away from 6/8. So I have 6/8. 6 minus 3 is 3. And then my denominator stays the same when we're adding or subtracting fractions. So 3/8 x minus 1/2 equals, well, I got rid of the 3/8 x on that side. So I'm done. Equals positive 4. Now, I don't have to write that positive, but now that I know it's positive, I'll erase that. I need to add 1/2, right? Because I'm trying to undo the negative 1/2, so add 1/2. Okay, so now I have 3/8 x equals 4.5. Now, I am going to make that an improper fraction because that's just easier to work with over here. So 3/8 x equals 4 times 2 is 8 plus 1 is 9. So 9/2. So I just converted that because it's easier for me to work with improper fractions. So how do I isolate x when I have 3/8? This is multiplication, right? So I need to divide by it. But dividing is the same as multiplying by the inverse, the reciprocal. So I have 8/3, right? That's the reciprocal of 3/8 because 8 times 3 is 24. 3 times 8 is 24. So 24/24 is equal to 1. So I'm multiplying 3/8 by its reciprocal because I'm trying to get it down to 1. So 1x equals, but if I multiply by 8/3 on that side, I need to multiply by 8/3 on the other side. I'm going to cross simplify always. 2 goes into 2 once, 2 goes into 8 4, 3 goes into 3 once, 3 goes into 9 3 times. 1x equals 12 over 1, or x is equal to 12. And if I wanted to, again, check this on my calculator, I'm going to do a better job this time modeling it for you. I'm actually on the calculator, I'm going to convert it to decimals just because I think it's easier. So I'm going to make 3/4, 0.75. So 0.75, and then I got to substitute my value for x. So 0.75 times 12 equals 9. And then 9 minus a half is 8.5. Okay. Let's go over here. So 3/8, let's see, 3 divided by 8, what's the fraction for that? All right, the fraction out. 3 divided by 8 is 0.375. So 0.375 times 12 equals 4.5, okay? 4.5 plus 4 equals 8.5. So therefore, I know that I did my equation correctly. So again, I don't mind if you, in fact, I encourage you to use your calculator at the end when you're substituting. You need to do all the work first to get your value for x. But once you get your value for x, I'm not really looking for you to just have a bunch of busy work, but I would like you to go back and take the value that you got and substitute it into the original equation to make sure that you get equal numbers on both sides of the equation, because then you know that you did it correctly. All right, you're going to do one more in Ed Puzzle for practice, and then you will have some independent practice on your own. I think I'm going to do it in GimKit. I haven't decided yet, but now that I've told you that, I guess I better stick with that. So GimKit it is. All right, bye.